Assalamu alaikum. Inshallah, today I'm going to speak about the distance relay communication scheme. In previous video, I was explaining about the distance relay zone setting, and we see that the distance relay, it have 4 zones. Zone 1 is cover almost 80% from my main line with time delay instantaneous or 0 second. And zone 2, this one is zone 1, and zone 2, it's cover almost 120% with almost time delay 0.4 second. And zone 4 or zone 3, this is zone 2, zone 3, it's cover 220% with time delay 0.8 second. And zone 4, it is reverse directional. Zone 4, it is reverse directional with time delay almost 1.5 seconds. And we see that to make the overlapping to our main line in substation B, we have also the distance relay here. We have also here distance relay, this 21 relay. So to make the overlapping, so I will make this distance relay to look this direction. So I will have in this direction, distance relay will have same setting what we have in distance relay in substation A. So this will cover 80% with time delay instantaneous. Okay, and zone 2 will be covered to 120% with time delay 0.4. and zone 3, this zone 3, this zone 2, and this zone 1, and zone 3 will cover 220% with time delay 0.8 second. Same setting what we have in substation A. And zone 4, he will look the opposite directional and with time delay 1.5 second. And we'll study some study cases, and we see that if the fault happen here, if the fault is happening here, this distance relay in substation B, he will see the fault in zone 1. He will see the fault in zone 1. So this breaker will trip instantaneous at 0 second. But the distance relay in substation A, he will see the fault in zone 2. See? He will see the fault in zone 2. So he will trip in 0.4 second. So this breaker will trip in 0.4 second. But this our main line should be clear the fault instantaneous. That's mean this breaker and this breaker should be tripped at zone 1 timing or instantaneous. So both breaker I needed to trip instantaneous. So to avoid to feed this fault up to 0.4 second, I need to clear the fault instantaneous. Because this our main line, so you should be clear the fault immediately. Should be there, no time delay. So how to make solution for this problem? So that's why we will use the communication scheme in distance relay. Mostly in communication scheme in distance relay, we have 3 types. One is called DUTT, and another one is called PUTT. The third one we call POTT. So we have these 3 types, and we'll explain one by one. So DUTT, it is mean direct underreach transfer trip. So how this communication it will be happen. Now let's do some study cases. In DUTT, in this distance relay we have TX and RX. Again in this distance relay we have TX and RX. TX is nothing, is only it is transfer terminal, and RX is receiving terminal. And mostly to make the communication between this distance relay by using FOC, fiber optical cable. So the most things to make the communication by this 2 distance relay by using the fiber optic cable. Now let's make the study cases and we implement same this fault. Now this fault, the distance relay in substation B, he will see the fault in zone 1. But the distance relay in substation A, he will see the fault in zone 2. So how the DUTT will work? After this distance relay see the fault in zone 1, immediately he will send transfer carrier signal to the distance relay in substation A to trip instantaneous. So any of this relay see the fault in zone 1, immediately he will send signal to another relay and both breaker will trip at zone 1 time delay. So both breaker will trip instantaneous. So now to make it clear, now assume the fault is happening here. If the fault is happening here, the distance relay in substation A, he will see the fault in zone 1, but the distance relay in substation B, he will see the fault in zone 2. So immediately, this distance relay, if you see the fault in zone 1, immediately he will send transfer signal to another distance relay in substation B to trip instantaneous. So that's why we call it direct. So that's why we call it direct transfer or direct underreach transfer trip. So how this DUTT it will work? Immediately any protection relay see the fault in zone 1, he will send the signal to another relay to trip instantaneous. It's very simple scheme. Now let's see the PUTT, the another scheme. PUTT, permissive underreach transfer trip. From its word, permissive, means there are some monitoring or some supervision or something needed to be checked before I give command to trip. Let's see how this will work. Now let's see implement the fault here. If you implement this fault here, the distance relay in substation B, he will see the fault in zone 1, but the distance relay in substation A, he will see the fault in zone 2. So the PUTT, how it will work? When the fault seed in substation A in zone 1, he will send signal to distance relay in substation A. But the distance relay in substation A, he will not trip directly. As the word permissive, that means something needs to be checked. So that's why here we have AND gate. And gate. So the AND gate, how must this work? Means this relay, he must see the zone 2. So the zone 2 here, they must pick up. That means if the fault is happening here, this distance relay, he will send signal to this relay. He will give him command to trip. But this relay, he will first check. Did I see the fault in zone 2? If he yes, they see the fault in the zone 2, he will send back signal to distance relay in substation B. He will tell him yes, I see the fault in zone 2. Then this distance relay, he will send the signal to the distance relay in substation A. He will give him okay, now everything's okay, let's trip. So both breaker, he will trip instantaneous. Just try to imagine how this communication between these two relay. So in DUTT, the zone 2 must pick up from one of those relay. If the zone 2 it's pick up, so both relay he will trip instantaneous. So the last one, it is POTT. It is permissive overreach transfer trip. So again, he will make the fault here, same location. This distance relay, he will see the fault in zone 1, and this distance relay, he will see the fault in zone 2. Same things, but here in POTT, both the distance relay must zone 2 pick up. So again, here we will have as the AND gate. So when the fault is happening here, zone 1, it will pick up. Then he will check zone 2 should be pick up. Then he will send the signal to another distance relay. The distance relay in substation A, they must see the fault in zone 2, so both breaker he will trip instantaneous. So in POTT, both relay they must see the zone 2. Both relay they must see the fault in zone 2. Now let's do another cases in POTT. Now assume the fault is happening here. This is the fault, okay? If you check this fault, the distance relay in substation A, he will see the fault in zone 2. He will see the fault in zone 2. But this relay in substation B, he will see the fault reverse directional. He will see the reverse directional. So this relay, he will send signal to another distance relay in substation B. He will say, I sense the fault in zone 2. Let's trip. But this distance relay, he will say, no. This fault is having reverse directional. So I will block this communication between us. So this distance relay, he will trip as the time delay 0.4 seconds. And he will work as the backup protection. And we will give chance to our another main protection here to trip instantaneous. So this case is this distance relay, he will trip at 0.4 seconds and he will work as the backup protection. So I hope this is clear to you, and I hope this video was helpful and clear to understand the communication scheme between the distance relay. Thank you so much.